Good afternoon. In this lesson, I'm going to walk you through the difference between polar and nonpolar molecules and how that affects their intermolecular forces. All right, so just a quick review. A nonpolar molecule like this C3H 2468, C3H8, will have a very even distribution of charge. So if you imagine a sea of electrons around this molecule, that none are going to be tugged to one side or the other, a very even distribution of charge, therefore it's nonpolar. However, a polar molecule, like this water molecule, has a part of the molecule that has more electrons, like the negative oxygen here. Therefore, it will have a negative charge. Then the other side of the molecule would be more positive, so it has fewer electrons. Polar means a separation of charge, this side being more negative, this side being more positive. Okay, what does that have to do with intermolecular forces? Well, remember the word inter means between, molecular, different molecules, and a force is a push or a pull. So if we're talking about IMFs, or intermolecular forces, we're going to be talking about the push or pull that happens between molecules. Basically, what holds molecules to each other or prevents them from really being attracted to each other greatly. All right, so some forces are really strong and some forces are not quite as strong when we talk about this intermolecular force of attraction. The difference between a strong and a weak goes back to the polarity. A nonpolar molecule will only have weaker London dispersion forces between its molecules. Therefore, it has weaker attractive forces overall, lower melting points, lower boiling points, and some of the interactions that you saw in our lab. A polar molecule, on the other hand, can have up to 3 intermolecular forces. London dispersion for sure, so both of them have London dispersion forces, but then because it's polar and one side has a charge that's different than the other side, it will actually make a dipole-dipole force. What that means, if we take a look at water as an example, this water molecule will find its way to attract to another water molecule, so it'd have an H, an O, and an H. This attraction right here happens because this is still a partial positive and this is partially negative. And those positives and negatives will attract to each other, creating that intermolecular attraction. All right, that's stronger. This is a dipole-dipole attraction because we're using the charges, the partial positive and partial negative. Then there's an other option where it might even be another force involved between the hydrogen and an oxygen molecule, or hydrogen and a nitrogen atom, or hydrogen and a fluorine atom. That creates a hydrogen bond. All these three work together to make really strong attractive forces. So when you're doing your poster and when you're trying to figure out what intermolecular forces are present, please take a look at if it's polar or if it's nonpolar. And that will tell you if it's nonpolar, we're only dealing with London dispersion forces. If it's polar, it could be all three. The way you'll know is if hydrogen also has the ability to connect to an oxygen, nitrogen, or fluorine. So look for those elements inside your compounds. Thanks. Have a great day.